Let's solve some absolute value inequalities. So here are three examples of inequalities that have absolute values in them. What we're going to do is treat it like an absolute value equation where we are splitting it up into its two cases, but we're keeping those inequality signs with them. So in this first one, we've got the absolute value of x is greater than 5. When we split this up, remember we keep what's originally inside that absolute value. We've got x is greater than 5, and then we've got negative x is greater than 5. Those are our two cases. But we need to get x by itself. So in this second case, we're going to divide by that -1. So x is now less than -5. So again, x is greater than 5, and x is less than -5. If you want to sketch a rough draft of what that graph might look like, here's 5, 0, and -5. We want everything smaller than -5 and bigger than 5. So if we were going to put that in interval notation, we've got our arrows pointing in both directions. That's going to tell us we need to use our infinities. So starting at -infinity, it goes all the way up to -5. We have that open circle, or that strictly less than. We're going to take our union. We jump over to +5. Again, we have a parentheses because of the open circle. And then we've got the arrow pointing to the right, so we're going towards +infinity. There's our interval. Now let's look at the absolute value of x less than -5. Again, two cases. X is less than -5, and negative x is less than -5. Divide by that negative and switch our sign, so now x is greater than 5. We have x less than -5, x greater than -5. This is exactly what we had in that first example, so we're going to have the exact same interval from -infinity to -5, and then jumping over from 5 to infinity. Close parentheses. Finally, we have the absolute value of x is less than 5. Two cases. X is less than 5, and negative x is less than 5. This becomes x is greater than -5. So if we want a rough sketch of this, here's -5, here's 0, and here's 5. We want to be smaller than 5, but bigger than -5. So this one is where we have that in-between space. So our interval now, since we don't have the arrows pointing in both directions, we want the space in between. We're just going to use our two numbers. And since they are open circles, both of those numbers get parentheses. Graph the solution set on a number line and write the answer in interval notation. So once again, we have the absolute value of something and an inequality. Two cases. 6y minus 5 is greater than or equal to 13, and negative 6y minus 5 is greater than or equal to 13. From case number 1, I'm going to add 5 to both sides. So 6y is greater than or equal to 18. Then we'll divide by 6, so y is greater than or equal to 3. From case 2, I'm going to divide by this negative in front, which will switch my sign. So now we have 6y minus 5 is less than or equal to -13. Add 5 to both sides. 6y is less than or equal to, and -13 plus 5 is -8. Then we can divide by 6, so then y is less than or equal to -8 over 6, which reduces to -4 over 3. So let's graph. We need everything greater than or equal to 3. So at 3, we've got a filled in circle, and our arrows go into the right because we want to increase that value, and less than or equal to -4/3. -4/3 is around -1 1/3. I'm just going to put that right here. This one is also a closed circle because we have that less than or equal to. And this time we are less than, so we are decreasing that value. It's going to the left. That shows me, ooh, I've got arrows going in both directions. We're going to go from -infinity all the way up to that -4/3. This time we had that filled in circle, or we had that less than or equal to, so we've got brackets. put our union, and we're jumping all the way to 3. This one also gets brackets, and then the arrow's going to the right forever, so it's going towards infinity. Remember, we're always doing our interval notation from left to right.